All right. Today, we are going to dive into a concept that is absolutely fundamental to modern networking, but it's also, honestly, really cool. We're talking about the virtual LAN, or VLAN. We're going to break down what it is, exactly what problem it was invented to solve, and how it basically gives network admins superpowers. Let's get right into it.
Okay, let's start with what I like to call the golden rule of networking. You really have to get this down. Switches are all about managing traffic locally, making sure data packets don't crash into each other. Those are collision domains. Routers, on the other hand, manage traffic between different networks, stopping network-wide shouts or broadcasts from causing total chaos. This separation of duties, well, it's the key to understanding everything that comes next.
But, here's the catch. While that golden rule is still 100% true, the way we physically build networks has changed a lot. And this new modern design has created a brand new challenge that the old rulebook just can't handle on its own. So if you looked at an older network design, you'd see a bunch of routers chopping the network up into little segments. But today, we rely almost completely on switches. It's way more efficient, way faster, but it creates this thing we call a flatter network. And that has one pretty major side effect.
And this is the part you really gotta get. When we say flat network, we're not talking about the physical layout of the cables. We're talking about how it communicates. It means the entire network is like one gigantic, wide open room. And when someone shouts in that room, sends a broadcast, everybody hears it. All those switches all linked together, they form one massive broadcast domain. Let's just pause on that for a second. A device sending out a broadcast is a totally normal, everyday network event. But what are the actual consequences when that happens inside this one huge single room we've built? This is what happens. The switch does its job, and its job is to blast that broadcast out of every single one of its ports. So every computer, every server, every printer gets that packet. And they all have to stop what they're doing for a split second to look at it and ask, hey, is this for me? Now imagine that happening with hundreds or even thousands of devices all shouting at the same time. So yeah, this leads to two gigantic problems. First, performance just tanks. The network gets incredibly chatty and bogged down with all this background noise. And second, it is a huge security problem. In a flat network, every device can see every other device. So your ability to keep, say, the finance department servers separate from the guest Wi-Fi is, well, it's pretty much non-existent. And that brings us to the million-dollar question, right? We want the amazing speed and low cost of a switch-based network, but we desperately need the segmentation that routers have always given us. How in the world do we get the best of both? Well, the answer is to stop thinking physically and start thinking virtually. We need a way to redraw the network map, to build walls and create new rooms, but without ever touching a single physical cable. And that's where the virtual LAN comes in. The word you need to focus on here is logical. A VLAN couldn't care less about physical location. You could have one person from the sales team on the first floor and another on the 10th floor, and with VLANs, you can put them in the same virtual group. It's like they're plugged into the same little switch, even though they're miles apart. It's all done in software.
And here's the magic trick. The instant you assign switch ports to a VLAN, the switch starts treating them like they're on a totally separate island. A broadcast from a computer in VLAN 10 will only go to other devices in VLAN 10. It is completely invisible to VLAN 20. We just created a separate broadcast domain using a switch.
This chart just lays it out perfectly. On the left, you've got the flat network, one noisy, insecure, chaotic room. And on the right, with VLANs, you have a building with multiple, quiet, secure offices. Broadcasts stay where they belong, performance shoots up, and now we can actually build security boundaries between departments. Okay, so this is awesome. We've successfully separated our networks. It's more secure, it's faster. But wait a minute. What happens when someone in the sales VLAN needs to print to a printer that's in the operations VLAN? We've kind of created a new problem, haven't we? It almost feels like a trick question. We brought in VLANs to give our switches some router-like features, right? To segment the network. So by separating everything, did we just make routers even more important? The answer is a clear and absolute yes. You still need a router, or at least a powerful switch that can do routing. And this brings us right back to our golden rule from the beginning. A VLAN is a broadcast domain. And what's the one device that lets different broadcast domains talk to each other? A router. It's that simple.
So let's trace the journey of a single packet. A PC in the sales VLAN, let's call it VLAN 10, needs to send a file to a server in the engineering VLAN, VLAN 20. The switch gets the packet and goes, whoa, this isn't for my little island. So it sends it up to its boss, the router. The router looks at the address, says, I know where this goes, and sends it right back down to the switch, but this time with a new ticket that says, deliver to VLAN 20. The router is the bridge between these virtual worlds.
So let's zoom out. When you put all of this together, what is the true game-changing power that VLANs give us? It really all boils down to one simple, powerful idea: segmentation. When you really think about it, the benefits are just massive. We've tamed that chaotic broadcast storm, which boosts performance for everyone. We've built virtual walls between departments, which is a huge security win. And maybe the coolest part, we can now group people and devices based on their job function, not where their desk happens to be. Honestly, if you only take one thing away from this explainer, let it be this. VLANs mean the physical wiring of your building almost doesn't matter anymore. An employee moves from the marketing team to the finance team, you don't have to run new cables to their desk. You just log into the switch, click a few buttons, and change their port from the marketing VLAN to the finance VLAN. Done. It's just that flexible.
It's a pretty mind-bending idea when you step back and think about it. A set of rules in software can completely redefine a physical system. And that really makes you wonder, right? Beyond just computer networks, where else are these invisible logical lines on a map proving to be way more powerful and important than actual physical walls? Something to think about.